Hey, fifth grade. All right, so since I've got the big board here, I'm going to keep going through all of these, obviously. So this is 11.2, which is about triangles, and triangles are pretty fun. So I think this is actually going to be a very easy lesson for you. So hopefully this will be a short video. We'll see. You know how I like to talk. All right, so when we're talking triangles, we need to talk about a couple of different things. First of all, let's talk about the angle part of triangle. There's three different types of angles. Okay, so you have an acute angle, which is less than 90 degrees. You have a right angle. Remember, we put a little square in there. That right, which is equal to 90 degrees. And we have an obtuse angle, which kind of looks like that. And obtuse means, I'm sure you can guess, more than 90 degrees. Or greater than, we'll use the math words. Greater than 90 degrees. Okay, so acute, right, and obtuse. Now, these are our three possible types of triangles, or types of angles within triangles, and really there are three possible types of angles within any polygon. Now, the interesting thing with triangles are you can only have two of the angles have to be acute. You can't have two obtuse angles and have it work out with triangles, right? So if you think about it, if we have like that, and then we have a second, like from here coming back to here, it's got to be small, right? These are acute. You couldn't, on a flat surface anyway, you couldn't go this way and get back over here with just three sides, okay? So you can't have, and the same thing with right, which you can think about, right angles are like in squares and rectangles. So if we have one right angle there, and we come over and we have another one here, well, this line is never going to touch this line. So you can't have two right angles. Kind of an interesting thing, if you think about it, on a globe, you can have two right angles in a triangle, because if you think about the Earth and the lines of latitude and longitude, right? If we start at the equator and we have two lines, so the equator, of course, is going around the globe this way. We have two lines that are going up and down, right? Our longitudinal lines. Those lines are going to come up and they meet at the North Pole. So you have two right angles down here, and up at the top you'll have an acute angle. But that only works on round surfaces. On flat surfaces, remember we talked about this is all on a plane, a 2D surface, doesn't work. But just kind of an interesting fun fact. I had to take a class in college that where we talked about geometry on a globe, and it was, or on a rounded surface, and it kind of broke my brain a little bit. All right, so anyway, sorry, I was off on a little tangent there. These are our three angles. Now, along with this, we have three types of triangles. All right, so first we have an equilateral triangle. Equilateral triangles means, well, basically it's a regular triangle. All sides are the same, are congruent, and all the angles are congruent. Okay, so equilateral triangle. So basically, that's not going to be perfect, but let's pretend that it is. All right, so all three of these sides are the same length, and all three of those angles are the same distance, angular distance. Okay, so that's an equilateral triangle. Notice all three of these angles are acute, and they have to be acute. Triangles, so the angle measures all add up to 180 degrees. Okay, that's important just in general for a lot of geometry. But also in this lesson, there's going to be at least one question, I think, that asks you, says, here's these two angles. Is the third one, what's the third one going to be, basically? And you just have to know that they all add up to 180 degrees. So when we talk about equilateral triangles, this one is 60 degrees, and this one is 60 degrees, and this one is 60 degrees. Okay? So that's an equilateral triangle. Our next type of triangle is an isosceles triangle. Oh, this is an S. Okay, so an isosceles triangle has two congruent sides and it also has two congruent angles. Okay, so an isosceles triangle could look, there's lots of different possibilities here. It could be something like that, right? It could also, assuming that these sides are the same, which means that these angles here are the same. It also could be something more like that, because those two lines are the same, and these two angles are the same. Okay, something like that. So in this case, this one, notice, has an obtuse angle here, right? Like this angle here is greater than 180 degrees, whereas these two are less than 180 degrees. So in your lesson today, it's going to be asking you to name the triangles. Last lesson, you had to name all the different polygons, right? And basically just had to say if it was regular or irregular, and then how many sides is it, and then just look up, what type of shape that is. So if it's got 5 sides, then it's pentagon. If all the sides are the same, then it's a regular pentagon. Okay? Here, they're all going to be triangles, but you're going to have to name the triangles very specifically. So in this case, this would be called an obtuse isosceles triangle. Okay, that's this one right here. This one, however, would be an acute isosceles triangle. Okay, just like that. Hopefully that makes sense. All right, but the big thing is isosceles has two congruent sides, two congruent angles. And then our last one, so if the first one, of course, was an equilateral triangle, which had 3 congruent sides, 3 congruent angles. Then we had an isosceles triangle, which had 2 congruent sides and 2 congruent angles. Then our last one is going to be scalene triangle, which of course has, well, it doesn't make sense to say that it has one congruent side, right? Because if it has one congruent side, then it can't have one thing that's equal to itself. So in this case, it has 0 congruent sides and angles. Okay, so none of the sides are the same, none of the angles are the same. All the angles will still add up to 180 degrees, but none of them are the same. So you could have something that's like, I don't know, something like that. These two sides are slightly different, this one's different, so it'd basically kind of be all those sides are the same. If all the sides are the same, then all the angles are different also. Let's see, so if we wanted to do, let's do like a right angle here. We could have this one come up really tall. And that one will be sort of short. And this one will be there. Okay. So this, we don't have to know this yet, but this this line here is called the hypotenuse, and it's going to naturally be longer than this line here. Okay, so that one's one angle. This is one side length. This is a slightly different side length, well, very different side length, and this one is slightly different. So here we would have a right scalene triangle. Okay. Now I try to remind my classes every year that when it comes to like deciding, what type of triangle it is, if you look at this triangle here, right, this is an acute angle here, and this is an acute angle here. So it feels like you should be allowed to just call it an acute triangle, but two of the angles are always going to be acute, like I said earlier. It's just the one angle that gives it its name. All right. So if you have one right angle, then it's a right triangle. If you have one obtuse angle, then it's an obtuse angle. If you have zero of those things, then all of the angles are acute, and that means that it's an acute triangle. Okay. So there's that. Yeah. For the assignment, it's basically just going to be having you name the triangles. Yeah. So really all you have to do is write, equilateral and, well, if it's an equilateral, it has to be an acute. So equilateral and acute, or obtuse, scalene, or something like that. It doesn't really matter on page 645. It doesn't matter which order you put the words in. You could have the name of the type of triangle first, and then you could have like what it is afterwards, acute or right or obtuse. Or you can put the word in front. It doesn't really matter. I don't care. Let's see. I think that's everything for this one. So yeah, looks like questions 4 and 5 don't give you the triangles. They just show you the angles and the side lengths, and you'll have to use that. Should be fairly easy. Anyway, good luck. As always, let me know if you need any help.